When you think about the cutting edge of AI, you probably picture these massive, almost mythical server farms.
Right. Huge budgets, billions of dollars, trillions of parameters.
Exactly. It's this race for scale.
Yeah.
Bigger is always better. But then you sent me this proposal from Neo DataNet Research in Ghana, and I genuinely thought it was a typo.
The budget, right?
The budget. They're proposing to build a foundational sovereign AI for the entire national health sector for $15,000.
It stops you in your tracks, doesn't it?
It really does.
Yeah.
My first thought was, okay, is this real? I mean, $15,000 is less than a cheap used car, not a national AI initiative.
It's real. And that skepticism is exactly why we need to talk about this document. It's the Sovereign AI Infrastructure Proposal for Ghana's health ecosystem. And it basically challenges the entire way we think AI has to be built.
Okay, so before we unpack the how, because that's the big question, let's talk about the why. Why not just, use a Google or an AWS API? It seems so much easier.
It is easier, and that's the trap. The proposal uses this really powerful term for it.
Which is?
Digital drain.
Digital drain. So it's like brain drain, but for money.
Precisely. Every single time a doctor in Accra uses a tool powered by a foreign AI, data goes out and cash follows it. You're effectively renting intelligence.
So it's a massive subscription fee at a national level.
It's a hemorrhage. The source puts the number for sub-Saharan Africa at around $4 billion a year.
$4 billion, just on imported cloud services.
And if you zoom right in on Ghana, they estimate that for just 5% of the formal workforce, the daily drain is somewhere between $150,000 and $200,000.
Wait, per day?
Every single day.
Wow, that's a staggering amount of capital leaving the country just to process its own data.
Exactly, and that's the central argument here. Ghana is, in their words, data-rich, but insight-poor. They have the information, but they're paying a toll to Silicon Valley to use it, and that creates what they call a sovereignty risk.
Sovereignty feels like a political word for a tech problem.
Well, it's about control, and it's also about physics.
Physics?
Latency. Your data has to travel from a clinic in Ghana to, say, a server in Virginia and all the way back. That round trip takes time.
How much time?
About 150 to 300 milliseconds.
Which, to be fair, is the blink of an eye.
In a chat app, yes. But in a national triage system with spotty internet, that friction adds up. And, more importantly, what happens when the internet goes down?
The system is dead in the water.
Your multi-billion-dollar rented brain is gone. You're back to pen and paper. And that gets to the human cost. WHO data cited in the proposal says clinicians are spending 70% of their time on administration.
70. So they're only being doctors for 30% of their shift.
Pretty much. And all that manual paperwork leads to errors, a 10 to 15% misdiagnosis rate.
Okay, so the problem is huge. Financial drain, clinician burnout, patient risk. Which brings us back to the $15,000 question. How is the solution so cheap?
Right, because I see you looking at the investment plan. You see 8x A100 GPUs. And you know one of those costs more than the whole budget.
I do, so what's the trick?
You don't buy them. You rent them. And this is the key. They're not building a giant general-purpose model like GPT-4 that can write poetry.
Hospital in Ghana doesn't need a poet.
It needs a specialist, a
Yeah.
very, very focused specialist. So they're building a much smaller model, around 120 to 350 million parameters.
Give me some scale on that. How small is that compared to the big guys?
Oh, it's microscopic. We're talking thousands of times smaller than something like GPT-4.
But doesn't that make it less intelligent?
It makes it less generally intelligent. For a specific task, it's incredibly efficient. Because it's so small, they can train it in just 4 to 7 days.
So they rent the supercomputer for a week, do this intense training sprint, and then they're done.
That's the plan. About 10 grand for the compute and build, 5 for the team. They use clever tricks like mixed precision and something called LoRa.
LoRa, I've seen that in the open source world. It's like a way to fine-tune a model cheaply, right?
That's a great way to put it. It's like you don't have to reteach the model the entire language. You're just adding a new, very specific chapter on, say, tropical medicine in West Africa.
Okay, that makes sense. But there's another term in here that really stood out to me. Pre-RAG.
Ah, yes. This is the real secret sauce.
Everyone talks about RAG, retrieval augmented generation. What is pre-RAG?
So with standard RAG, the AI works like a student with an open book test. It gets a question, it goes and looks up the answer in an external database, and then tells you.
Which is great for staying up to date.
It is, unless the library is closed.
The internet is down.
Exactly. For a rural clinic in Ghana, You can't rely on a constant high-speed connection. Pre-reg, or what they call embedded intelligence, is different.
How so?
The model has already memorized the textbook. The knowledge is baked right into the model's weights.
So it's a closed book test.
But the student has a photographic memory. It works completely offline. It doesn't need to call home to a server in California.
That's a game changer for reliability. It's the difference between streaming a song and having it downloaded to your phone.
Perfect analogy. And for that to work, it has to have memorized the right books.
And this is where the sovereignty part comes back in, I assume. It can't just be American medical data.
You're spot on. That's the problem with using a generic model. This one is trained specifically on local data. They're using demographic and health surveys from 15,000 Ghanaian households.
So it understands the local population?
It knows the people. It's also using data from over 4,000 Ghana health service facilities. And, my favorite part, the Lacuna Fund dataset.
What's that?
20,000 maternal health questions and answers.
Okay.
In Twi.
In the local language?
In Twi. So if a patient uses a local phrase to describe a symptom, this model understands it. A generic model would just get confused.
Wow. Okay. I'm sold on the tech. It's small, offline, and it's actually Ghanaian. But let's make this real. What does this look like on a Tuesday morning in a busy clinic? Let's walk through their patient journey.
Okay, let's do it. Stage 1, intake. Right now, it's messy, paper forms, things get missed.
Right.
With this system, the AI prompts the nurse. It knows it's the rainy season and malaria is high in that specific area, so it flags, hey, ask about recent travel, check for fever.
So it's not just a dumb form, it's an intelligent assistant.
And that alone makes triage 50 to 100% faster. Then you get to stage 2, queue management,
The waiting room.
which is often chaos. The AI uses official Ghana health service protocols to prioritize patients. It sees a pediatric case with certain symptoms and bumps it to the front of the line instantly.
So the sickest people get seen first, automatically.
Correct. Then stage 3, the actual consultation. The AI acts as a co-pilot for the doctor.
Is it telling them what to do? I could see some doctors pushing back on that.
It's decision support, not a replacement. It will listen to the symptoms and generate a ranked list of possibilities. Malaria, 60% likelihood, typhoid, 20%.
So it's a second opinion right there in the room.
Exactly. It's a safety net to catch that 10-15% error rate. It saves the clinician about 10-20 minutes per consultation.
Okay, and then treatment, stage 4.
This is a big one. They mention a 5-10% rate of dosage errors.
That's terrifying.
It is. The proposal gives a specific example. The malaria drug artemether-lumefantrine.
I am not going to try to say that.
The dosage is complex. It depends on weight and age. The AI calculates the exact dose instantly, which reduces the risk of human error when a doctor is tired.
It takes the mental math out of it.
Precisely. And then finally, stage 5, discharge and admin.
The paperwork.
The boring part that is actually critical, the AI auto-generates a discharge summary that is NHIS audit-ready.
NHIS is the National Health Insurance Scheme.
Yes. And if the claim paperwork isn't perfect, the insurance company rejects it. The hospital doesn't get paid for the care they provided.
So the AI is literally making sure the hospital stays in business.
It protects the revenue. It ensures they can buy supplies and pay staff. It closes the loop.
That's incredible. Better care, safer treatment, and the hospital actually gets paid. All from this tiny offline system.
And the proposal looks even further ahead. They talk about this being digital public infrastructure, or DPI.
Right, the economic multiplier.
Exactly. There's data that shows for every 10% increase in digital access, you get about a 1.4% bump in GDP. This system is designed to remove that digital friction.
And they have a vision to scale this beyond just one hospital, right?
Yeah. They see this as a reusable microservice for the whole Ministry of Health. But their 3-year vision is even bigger.
The export plan.
They want to build an 18-megawatt AI hub and position Ghana as an AI exporter to the rest of the ECOWAS region.
The Economic Community of West African States.
Right. Think of Nigeria, Togo, Ivory Coast. They all have similar diseases, similar challenges.
So a model trained for Boston is useless to them, but a model trained for Accra.
It's highly relevant. They could sell that. They estimate the potential infrastructure value at over $500 million.
That completely flips the script. It's not about tech aid from the West. It's about the global South building a better, more relevant tool and selling it.
It changes the entire power dynamic.
Yeah.
And because they're building it themselves, they own it. It complies with Ghana's own data protection laws.
Something you can't guarantee with a foreign black box.
You can't. This is what true sovereignty looks like.
So what's stopping them? If this is so compelling, what's the next step?
Well, the proposal ends with a call to action. They have a 36 million parameter prototype ready.
Ready to demo.
Yeah. They need to engage with the government, with the Ministry of Science and Technology, to get access to GPU clusters.
They need to compute.
They need the compute. But when you weigh that small ask against the $200,000 a day problem they're solving,
It feels like a no-brainer. A very low-risk, incredibly high-reward bet.
it really is. And that's what's so fascinating. We're all watching these tech giants wage war with these unbelievably massive AI models, assuming that's the only path forward.
We assume bigger is better.
Right. But what this proposal from Ghana suggests is that maybe, just maybe, a small, focused, context-aware model can actually outperform a giant.
It's the difference between a Swiss Army knife and a scalpel.
And in a hospital, you want the scalpel.
And you want to own the scalpel, not rent it by the second.
Yeah,
It makes you really reconsider what the future of this technology looks like.
it does.
I want to leave you with this thought to chew on. Maybe the future isn't one single giant AI living in the cloud. Maybe it's thousands of these small, sovereign, $15,000 AIs running offline, speaking local languages, and solving real-world problems in ways the giants never could.
That's a future that sounds a lot more distributed and, frankly, a lot more equitable.
It certainly does. We will be keeping a very close eye on this one. Thanks for walking us through it.
My pleasure.
See you next time.